Lesson 23, Important Characteristics to Describe. Descriptive statistics methods are used to summarize and describe important characteristics of data. Primarily, there are three important characteristics statisticians focus on in order to provide an overall summary and useful description of results. The three important characteristics to describe are the distribution of the data, the central tendency of the data, and the dispersion of the data. The distribution of the data describes the overall pattern or shape of the data values. Graphical descriptive statistics methods such as a distribution table, Pareto chart, pie chart, histogram, and stem and leaf plot are well suited for displaying the distribution of the data. When dealing with qualitative data, the construction of either a distribution table, Pareto chart, or pie chart is recommended to facilitate the description of the distribution of the data. When dealing with quantitative data, the construction of either a distribution table, histogram, or stem and leaf plot is preferred for displaying the distribution of the data. To describe the distribution of data that falls at the nominal level of measurement, each category is identified along with its corresponding frequency or proportion. To describe the distribution of data that reaches the ordinal, interval, or ratio level of measurement, statistical terminology illustrating the pattern or shape revealed by the data values can be utilized. For instance, data that exhibits this pattern is referred to as bell-shaped. The bell-shaped distribution has characteristics where the higher frequencies are in the center and the lower frequencies are at the ends. So this overall pattern of low to high to low across the distribution of the data is symmetric. That is, you get the same extension in both directions around the center. Data that follows the bell-shaped distribution follows the general characteristics that there's a certain expected value, and most of the data occur in that center or expected value range. But not all data occurs at that center or expected result. Sometimes the data falls a little short than expected, or sometimes go a little beyond what's expected, but that doesn't happen too often. So most of the time the data occurs around the center, thus leading to the higher frequencies in the center. But once in a while, data will either be below the center or above the center, but that doesn't occur very often, thus leading to the lower frequencies at the end. For instance, data that exhibits a multi-bell-shaped pattern is data that has multiple bell-shaped curves. That is, there's more than one of these low, high, low patterns, low, high, low pattern in the data. So multi-bell-shaped distributions can have 2, 3, 4, or more bell-shaped patterns within it. Data that exhibit multi-bell-shaped patterns is usually the result of data collected from a population from which there are multiple subpopulations within that one population, thus generating these multiple bell-shaped curves. For example, we could collect data and the resulting pattern for males and females is different, thus exhibiting different bell-shaped curves for both of the males and the females. For instance, data that exhibits a positively skewed shape distribution show the characteristics of being lopsided. That is, the higher frequencies are off-center and the overall pattern is asymmetric. That is, data values extend much further in the positive or increasing direction than they do in the negative or decreasing direction, thus giving the description of being positively skewed. For instance, data that exhibits a negatively skewed shape distribution provides a distribution that is lopsided. That is, the higher frequencies are off-center and the overall pattern is asymmetric. That is, the data values extend much further in the negative or decreasing direction than they do in the positive or increasing direction, thus leading to the term negatively skewed. Whether the data is positively skewed or negatively skewed, skewed distributions are an indication that on the side where the data does not extend very far is an indication that it's very near some limit or barrier. On the other hand, the side of the distribution that extends much further is usually an indication that the barrier is not reached or is very far away. For instance, data that exhibits a uniform shape distribution provides a distribution where the data values are evenly distributed all across the data values. That is, there are equal frequencies amongst all the various data values. So there are many more types of shapes and distributions within statistics, but these are the most prevalent ones that we'll see. So knowing these types of distributions can go a long way in helping you describe the overall distribution of the data. The central tendency of the data describes the overall average, center, or typical result of the data values. Numerical descriptive statistics methods, such as the mean, median, and mode, are designed to measure the central tendency of the data. The dispersion of the data describes the variation, spread, or diversity of the data values. Numerical descriptive statistics methods, such as the standard deviation, median absolute deviation, and variation ratio, are designed to measure the dispersion of the data. When dealing with qualitative data, determining the mode and the variation ratio is recommended to facilitate the description of the central tendency and the dispersion of the data. This recommendation is necessary since the mean cannot be calculated for qualitative data, and the median cannot be determined with qualitative data that falls at the nominal level of measurement. For instance, use appropriate descriptive statistics methods to describe the important characteristics of the political party affiliation data, that is question 2 from our Sierra College Elementary Statistics Student Survey. So when we want to describe the important characteristics of data, we need to focus on the 3 primary important characteristics. That is the distribution, the central tendency, and the dispersion of the data. Now the data in this instance is the political party affiliation. And political party is qualitative, that is categorical data, that falls at the nominal level of measurement. So the appropriate descriptive statistics methods that we use with qualitative data when it comes to describing the distribution is to construct either a distribution table, or a Pareto chart, or a pie chart. And the appropriate descriptive statistics method to use to measure the central tendency of data that is qualitative is the mode. And the appropriate descriptive statistics method to use to describe the dispersion of qualitative data is the variation ratio. So in a previous example, we had constructed a pie chart for the political party affiliation of Sierra College Elementary Statistics students. The pie chart here displays the distribution of the data. And here we can look at the individual political party affiliations along with their corresponding percentages. So here we have 47.7% of the sample was Republican, 22.7% of the sample was Democrat, 20.5% were independent, and the remaining 9.1% were other. The mode is the data value that is most frequent, and so the 47.7% of the sample, which was Republican, was the most of any political party affiliation, gives us a mode of Republican. And the variation ratio is the percentage of the data that is not the mode. So since there were 47.7% Republican, that was the mode, the remaining 100 minus 47.7%, or 52.3%, would be the proportion that is not the mode, which is our variation ratio. Now, if we use words of the problem to describe each of these characteristics, we can get an overall description of this data. More Sierra College Elementary Statistics students identified themselves as Republican, 47.7%, than any other political party. There were about the same percentage of students choosing Democrat, 22.7%, as those who selected Independent, 20.5%. The remaining 9.1% picked other. The variation ratio for the political party affiliation of Sierra College Elementary Statistics students was 52.3%. When dealing with quantitative data, in most situations, calculating the mean and the standard deviation is preferred when describing the central tendency and the dispersion of the data. The exception is when the mean, which is the balancing point of the data, is distorted by the presence of outliers, that is, extreme data values, in the data. When dealing with quantitative data that includes outliers, calculating the median and the median absolute deviation is preferred when describing the central tendency and the dispersion of the data. This preference is justified since both the median and the median absolute deviation are resistant to the presence of outliers. For instance, use appropriate descriptive statistics methods to describe the important characteristics of the number of TVs in Rockland household sample results. So when describing the important characteristics of data, we need to describe three aspects: the distribution of the data, the central tendency, and the dispersion. Now the data here was number of TVs in Rockland households. So the number of TVs is quantitative data that's of a discrete type that falls at the ratio level. So the appropriate descriptive statistics methods when trying to describe the distribution of quantitative data is to construct either a distribution table, a histogram, or a stem and leaf plot. Now, in order to describe the central tendency or dispersion of quantitative data, we need to further decide whether we have outliers or not. So, recalling the example, a number of TVs in Rockland households, there were no outliers. Just the number of TVs ranged from a low of 1 to a high of 5. There were no extreme data values. So, the appropriate descriptive statistics method to use to describe the central tendency of quantitative data that contain no outliers is to calculate the mean. And the appropriate descriptive statistics method that will describe the dispersion of quantitative data that contains no outliers is the standard deviation. So in a previous example, we had constructed a histogram for the number of TVs in Rockland households, providing this overall pattern, where the frequencies from number of TVs start out low, then get high in the middle, and then go low again, in an overall pattern which is symmetric about that center, giving the bell-shaped pattern. Also in a previous example, we used the TI-84 calculator to calculate the mean for this data, which was 2.75. And the TI-84 calculator also helped us calculate the sample standard deviation for this data, which was 1.22. Stating in words each of these results gives us an overall description of the data. For this sample, the number of TVs in Rockland households resembled a bell-shaped distribution, with a mean of 2.75 TVs and a standard deviation of about 1.22 TVs. For instance, use appropriate descriptive statistics methods to describe the important characteristics of the age data, that is question 4, from our Sierra College Elementary Statistics Student Survey. So in order to describe the important characteristics of data, we need to refer to the three primary characteristics, that is the distribution, the central tendency, and the dispersion of the data. Now the data in this instance was the age of students, and age is quantitative continuous data that falls at the ratio level of measurement. The appropriate descriptive statistics methods that are used to describe the distribution of quantitative data would involve the construction of either a distribution table, a histogram, or a stem and leaf plot. Now, in order to determine the appropriate descriptive statistics method that will measure the central tendency and the dispersion of quantitative data, we need to establish whether there's a presence of outliers or not. And if you recall in a previous example, we've determined that there was an outlier in the age of Sierra College Elementary Statistics students. So the appropriate descriptive statistics method that's used to describe the central tendency of quantitative data that includes outliers is the median. And the appropriate descriptive statistics method that's used to measure the dispersion of quantitative data that includes an outlier is the median absolute deviation. So in a previous example, we were able to construct the stem and leaf plot for the age of Sierra College Elementary Statistics students. And if you look at the overall pattern, you can see that it is lopsided. That is, the ages extend much further in the positive or increasing direction than they do in the negative or decreasing direction, thus providing us with a positively skewed shape distribution. Also, with the aid of the TI-84 calculator, the median age was calculated to be 21 years, and the median absolute deviation was calculated to be 1 year. Putting in words of the problem each of these results, we can get the overall description. The age of Sierra College elementary statistics students has a positively skewed shape distribution with a median age of 21 years and a median absolute deviation of 1 year. So, in order to summarize, there are 3 important characteristics to describe: the distribution, or overall pattern or shape of the data, the central tendency, or the center or average of the data, and the dispersion, or the variation and spread of the data. Now, if the data includes quantitative data with no outliers, the appropriate graphical methods that will describe the distribution of the data is a distribution table, histogram, or stem and leaf plot. The best measure of central tendency for quantitative data with no outliers is the mean. And the best measure for dispersion of quantitative data with no outliers is the standard deviation. But when we have quantitative data that includes outliers, still the distribution is displayed by either making a distribution table, a histogram, or stem and leaf plot. But the best measure for central tendency with the presence of outliers is the median. And the best measure of dispersion when there's the presence of outliers is the median absolute deviation. Now, if the data is qualitative or categorical, then the distribution is best displayed by constructing a distribution table, a Pareto chart, or a pie chart. And the best measure for central tendency with qualitative data is the mode, and the best measure of dispersion with qualitative data is the variation ratio.